Scan data is the easiest way to read turbocharger boost and wastegate activity. On our scan screen here we have engine RPM and then the actual boost pressure as measured inside the intake manifold with a simple 3-wire pressure sensor. Here is desired pressure, what the computer thinks the pressure should be at any given RPM. Now, this is not a computer-controlled turbocharger, so this is used for diagnostics. It's not to control the boost pressure. The wastegate at the bottom is what controls the boost pressure, and it's in percentage of open. As an example, 0% would indicate that it's completely closed. In our scan screen, we can see that RPM is ever increasing. It's going up there from the halfway mark over to the right. So at any given RPM, what should pressure be? What does the computer think it should be? And when we look down here, we can see that the computer is changing its mind at different RPMs what the boost pressure should be. This screen tells us exactly what the pressure is as measured by that sensor in the intake manifold. And we can see that it does compare to what the desired is. That simply means that the computer is not going to set a code for the turbocharger boost because they look similar here. The turbocharger is able to follow along with what the plan should be. And how is that happening? It's down here at the bottom. It's the wastegate activity. The wastegate activity is keeping the boost under control, and it's doing so exactly how the computer thinks it should be. So we know we have boost from the turbocharger, and we know that it compares to what the computer thinks it should be. If we look over to the left-hand side, at this given moment, we see 24 psi actual and 26 psi desired. Anytime we have a desired PID, we use it as a specification. Now, we also told you that when the load is changing dynamically, in this case we're changing the throttle, we can't actually just say, hey, we're 2 psi off here, 24 for actual, 26 for desired. We have to allow the engine to settle down at any given load or speed in order to see is actual closer to desired. And then we know that the wastegate is working because it's controlling that action. When we look at this scan screen here, we can see that over on the left-hand side, the boost pressure is actually what the desired pressure should be. That means the engine has been stabilized, and now the desired allows the actual to catch up. Here the wastegate is at 0.3. That's a very small amount of opening. We could say it's just cracked open in order to give the boost pressure of what's desired. Now this is based off that spring inside the wastegate itself. That wastegated spring is actually calibrated to control boost pressure, and in this case it's doing a good job. Here we can see where the actual boost pressure and the wastegate are working together, but the one I want to point out to you on this screen is the pressure sensor voltage. This is from that, once again, simple 3-wire pressure sensor in the intake manifold. Now, if your boost pressure doesn't match your desired, if the engine has low power and we think it's not coming from the turbocharger when it should be, if we suspect something wrong with the turbocharger and or the wastegate, always check that pressure sensor first because that's what the computer is basing its information from.